Welcome to Sleep Science Top 1. Tonight, we immerse ourselves in the hidden world of amphibians. Frogs are fascinating storytellers of evolution. These resilient beings thrive at the very crossroads of earth and water, woods and deserts. For millions of years, frogs have stood as ancient witnesses to our planet's evolution. Frogs have been witnessing the changes in the planet. We frequently ignore them as basic pond critters. However, they are one of the most successful organisms to have ever existed. They have adapted, altered, and survived in practically every environment on Earth. In this world, soft nighttime symphonies unfold beneath a canopy of stars. Their hidden life, blossoming beneath foliage, pools, and moonlit surfaces. Frogs are the fascinating storytellers of evolution, messengers of environmental change, and the quiet engineers of the environments they inhabit. The more you listen to their story, the more surprising and layered it gets. As we proceed through this adventure, you may begin to notice how much intricacy can exist in something so small, and how much wonder there may be in the natural world. If this exploration resonates with you, you're welcome to continue exploring with us. One drowsy soul at a time, it assists others in making their way here as well. But for now, allow your shoulders to soften, let your breathing calm, and allow the day to melt away while your mind unwinds into this intriguing environment. Let's get started. Frogs are biological wonders, breathing through their lungs, their skin, and even the delicate lining of their mouths. Breathe slowly, and consider that there are multiple ways to accomplish this. Many frogs have lungs that allow them to draw oxygen from the air, but they may also exchange gases directly through their moist skin. This implies that a frog at rest can remain motionless for extended periods of time, as its body silently exchanges carbon dioxide and oxygen with its surroundings. In order to facilitate the exchange, some species can even employ the moist tissues inside their mouths, which is useful for hiding or keeping their head above water. This versatility is one reason frogs can live in settings where oxygen fluctuates from moment to moment. It also explains why environments that are moist and clean are so important. Their respiration is not blocked behind fur or feathers. It is directly on the surface, conversing with the surroundings all the time. Some frogs can freeze solid in winter, then defrost and hop away. In the freezing cold, some frogs do not run or burrow far enough. Instead, they experience the unfathomable. As temperatures plummet, ice can build in their body, and the frog becomes motionless. The heart stops beating, pauses in breathing. To the naked eye, life seems to have vanished. However, deep within, a complex chemical ballet is preserving every cell. Certain frogs flood their tissues with natural chemicals that help protect cells from harm. Thus, critical structures don't burst, and ice builds in safer locations. When spring temperature comes, the frog slowly restarts. The heart starts over. The muscles awaken. It might move as if nothing had occurred in a matter of hours. This remarkable survival feat is far more than just a biological curiosity. It's an evolutionary masterstroke. Seasons that would ordinarily wipe out a little mammal have an answer. It serves as a reminder that life can endure by defying the laws we take for granted. The world's smallest frogs are barely the size of a fingernail miniature marvels of the forest floor. The world can appear to shrink to a scale that most people are unaware of amid a moist patch of forest leaf litter. A single raindrop might feel like a significant weather event for some of the smallest frog species. At that size, survival becomes a game of hiding in plain sight. They eat microscopic invertebrates and pinhead insects. They live in the thin, damp areas beneath leaves, within moss, and in moist soil. Being little also impacts how sound and movement work. A short jump might still be a perilous adventure, and a gentle call can still matter in the dark. These mini frogs remind us that rainforests are not simply about towering trees. Additionally, they are about little lives in a universe measured in centimeters, with narrow borders and rapid heartbeats. With origins in prehistoric amphibians, frogs lived before dinosaurs. Early ancestors of frogs were busy traversing the planet long before tall dinosaurs dominated it. The frog's body plan has a long history, as evidenced by fossils: a wide head, strong rear legs, a form designed for short bursts and unexpected escapes. Over millions of years, that basic design proved so effective that it endured while continents migrated and climates transformed. Frogs were not new when dinosaurs first appeared. By adjusting to wetlands, woods, and shifting shorelines, they had already become a part of the landscape. Thinking about that chronology can be disorienting. A species small enough to fit in your palm possesses a history that extends back through major extinctions and prehistoric eras of Earth. Frogs of today are not remnants of the past. They have tried and true remedies and are survivors. Each spring call and each peaceful pond ripple is related to a genealogy older than many of the sights we envision as timeless. Many frogs drink water through skin patches on their belly and thighs. They have certain skin regions, usually on the underside of the body and around the thighs, that are capable of directly absorbing water. When a frog sits in damp soil or shallow water, it can draw moisture into its body without lifting its head. This is significant because frogs' porous skin allows them to rapidly lose water. Dehydration can happen more quickly in dry air than you might think. Water is easily and steadily absorbed through the body's surface. It also influences how frogs choose their resting locations. Comfort or crisis can be determined by a muddy edge or a patch of damp leaf litter. This is one reason frogs are so tightly related to healthy wetlands. Water is not only where they reside, they absorb it through touch rather than by swallowing. It's part of their nature. Some frogs carry tadpoles on their backs to savor water. Water can be found everywhere in a jungle, yet it can still be difficult to find in the proper form. Some frogs solve this by acting as small transport pilots. After the eggs hatch, an adult can let tadpoles cling to its back and climb or hop to safer pools. A tiny pool of water contained in a plant or a puddle that isn't as full of ravenous predators could be the destination. This is not a random ride. It is an intentional shift toward improved odds. Along the route, the tadpoles stay moist and covered, and they avoid extended swims across perilous channels. It entails additional work and exposure for the parent. For the young, it can be the difference between fading in a day and developing strong enough to transform. This behavior turns the forest into a map of nurseries, and the frog into a diligent guide, choosing the finest sites for the next generation. Frogs are sensitive indicators of pollution because they readily absorb toxins. The skin of a frog is not a waterproof clothing. It is a functioning surface that takes in water and exchanges gases, which also implies it may take in dissolved chemicals from the places it inhabits. That makes frogs extremely sensitive to what is happening in a wetland, a ditch, or a stream border. When contaminants enter the water, frogs may reveal the consequences earlier than many other animals because exposure happens via contact as well as through feeding. Developmental, behavioral, and survival changes can occasionally occur before people realize something is off. Frogs serve as early warning indicators for the condition of the ecosystem in this way. When frogs are thriving, it frequently means the water is supporting life in a balanced way. When frogs struggle, it can be a clue to examine closer. They are not exclusively dwellers of marshes. These are real-life accounts published in Biology and Skin. The largest frogs can be longer than a human forearm. There are places where a frog is not a little background creature. It is a heavyweight presence. Despite their enormous size, the largest frogs in the world feel more like powerful animals than delicate amphibians. The landing has weight when a person jumps. When one sits still, it can look like a smooth stone that breathes. Size changes everything. A huge frog can attack greater prey, and it has fewer predators that can consume it whole. It can also secure ideal places along riverbanks when food arrives on the stream. In some locations, people have long shared legends about these giants because they are hard to forget once you have seen one. They show how far the frog blueprint can stretch, from tiny leaf litter sprinters to strong riverbank athletes, all sharing the same basic idea of existence. A frog's tongue flies out swiftly and sticks, using sophisticated saliva mechanics. A frog does not grab for food the way we do. It takes off. The landing is only half the trick. The tongue can whip forth with amazing speed. The true marvel is the stick. A frog's saliva is a physics-defying wonder, a non-Newtonian fluid that shifts its viscosity in an instant to secure its prey, which means it varies its flow depending on force. It can spread and grab upon impact. It can then move once more to maintain its hold on the prey throughout the retreat. The tongue itself is also built for this job. It can be sufficiently pliable to encircle an insect just enough to increase contact. The outcome is a fast, reliable capture approach that works in weak light and dense foliage. It also explains how physics shows itself in everyday life. A frog does not need claws or sharp teeth to catch a meal. In an instant, it makes advantage of elasticity, timing, and a tiny layer of sticky fluid. Some frogs may change color to accommodate temperature, light, or mood. A frog can look like it is sporting a new coat without ever moving. Color change in many species occurs from unique skin cells that may expand or contract, modifying how pigments and light-reflecting layers look. Certain frogs can absorb heat by darkening in colder climates. In bright surroundings, others may lighten, which can reduce heat gain and also help them blend in. Social situations might play a role too. During breeding season, colors might intensify as messages to rivals or potential partners. This is not the instant dramatic trick of a movie monster. It is a living adjustment, adjusted to the frog's demands and surroundings. It also means that one frog can look different from morning to night, or from shade to sun, without altering species or identification. The skin becomes a receptive surface, tracking the world like a silent mood ring. When a frog swallows, its eyes aid in pushing food down. If you watch a frog eat, you could notice a peculiar movement. The eyes seem to sync or blink in a slow, purposeful fashion. This is not merely expression. A lot of frogs transfer food from their mouths to their throats by using the motion of their eyes. It is a clever approach for an animal that often consumes prey whole and does not chew. The eyes sit in bony sockets that connect to the roof of the mouth. When the frog pulls the eyes downward, it adds pressure within the brain, helping guide a struggling insect or wiggling worm deeper into place. It is like having built-in plungers that work from above. Once you realize this, a frog's face becomes even more fascinating. A seemingly straightforward blink can function as a component of the swallowing machine, utilizing anatomy in a way that is unexpected and oddly graceful. In order to obtain nutrition, many frogs shed their skin. It is not passive to wear frog skin. It is living, active tissue that needs to maintain its health and functionality. Over time, the outer layer wears off and must be replaced. A frog can wriggle and pull the old layer forward during shedding, frequently peeling it off in one piece, like a thin suit. Then comes the part that surprises people. Many frogs devour the discarded skin. For them, it is not a waste. It is a quick meal that replenishes the body with minerals and proteins. It also reduces traces that might attract parasites or predators. This habit reveals how carefully frogs manage resources. Recycling is important in a world where food can be unpredictable. It also emphasizes the extent to which a frog's skin serves as both a working organ and a boundary. Eating the outcome is efficiency, and shedding is maintenance, all rolled into a little nightly ritual. Rats, small reptiles, and even other frogs can be consumed by larger frogs. The menu is altered by size. Large frogs are not just for flies and mosquitoes. Under the correct circumstances, it can capture prey that surprises most people, including tiny rodents, young snakes, small lizards, and occasionally smaller frogs. This does not mean a frog is constantly hunting big animals. It implies that it can seize opportunities that arise along banks and near bodies of water. It is possible for a struggling animal at a pond's edge to suddenly become food. This rule can make large frogs important regulators of shoreline life, especially in places where many young animals gather to drink. It also makes them competitors with other predators, including birds and snakes that hunt the same edges. It's a startling contrast. Beneath that unassuming exterior lies a silent, lightning-fast predator. Yet for smaller animals, a big frog can be a silent trap with a wide mouth and fast reflexes, waiting for one careless step. Certain frogs have teeth, like bumps, that grip slippery prey. Frogs are not famous for teeth, yet some have small tooth-like structures that work like gripping tools. These are not the slicing teeth of a wolf. They are more like tiny bumps or ridges that help hold prey that would otherwise wriggle free. Wet environments frequently contain slippery foods, so a frog that captures a small aquatic animal or a slick insect needs a way to prevent it from slipping out during the struggle. Since many frogs swallow quickly and do not chew to secure food, grip is important. A slight hold improvement can make the difference between escape and dinner. This further demonstrates how evolution frequently favors minor adjustments that serve a useful purpose. A frog can succeed without a mouthful of daggers. For a quick grab to become a safe capture, it needs just enough traction. Tiny textures can sometimes determine survival. Most frogs cannot chew, so they swallow prey whole. A frog's meal is often a single gulp. Many frogs rely on timing and speed because they can't chew like humans can. They capture prey, then swallow it whole, often while the prey is still moving. That can sound simple, yet it demands a body built for quick handling. The jaw and throat must coordinate, and the swallow must happen before the prey escapes. This feeding style also shapes what frogs can eat. Prey must fit the mouth, and it must go down in one piece. For this reason, a lot of frogs prefer insects and other tiny creatures that can be controlled with a single movement. Additionally, it intensifies the moment of capture. Repositioning while chewing is not an option. The decision is made all at once. In that way, a frog's feeding is like a fast gamble with high stakes, played out in a blink on a damp stage. The journey of a frog begins with a radical metamorphosis, from a water-bound tadpole to a land-dwelling marvel. A frog begins as a small, soft beginning in water, then becomes something entirely different. In a watery world, the early stage is designed for swimming and feeding. Gills do the work of pulling oxygen from water, and a tail becomes the main engine. The body undergoes a transformation over time that resembles something from science fiction, but it occurs annually in ditches and ponds. Legs emerge. The head changes. The diet shifts. It also changes in how it moves. It is not just growth. It is a complete redesign from a form suited to water into a form that can explore the edge between water and land. That journey is one reason frogs have captured human attention for centuries. They are living proof that nature can rewrite a body without losing the thread of identity. Poison dart frogs get their toxins from diet, not from magic skin. Those bright colors are not decoration. In many poison dart frogs, they are a warming sign that says, "Do not touch." What makes this even more surprising is where the danger begins. The toxins are not made from nothing. In the wild, these frogs build their chemical defenses by eating certain tiny prey, often specific ants and mites that carry potent compounds. The frog stores and modifies those chemicals, turning meals into protection. This link between diet and defense is so strong that captive frogs raised on ordinary food can lose much of their toxicity over time. It is a vivid example of ecology working like a chain. What a frog eats shapes what the frog becomes. The colors, the risks, and the survival strategy are all tied to the forest floor. Change the menu, and the whole story changes with it. Frogs hear with eardrums, but also through vibrations in their bodies. Sound is not only something frogs hear, it is something they feel. Many frogs have visible eardrums on the sides of the head, and those membranes transmit vibrations to the inner ear. Yet frogs can also sense vibrations that travel through the ground, through water, and even through their own bodies. This matters when they are sitting on a bank or floating with only part of the head above the surface. Frogs are master seismologists, sensing the faintest tremors that ripple through their environment. About approaching footsteps, splashing predators, or nearby calls. Some frogs are tuned to very specific frequencies, which helps them pick out their own species in a crowded nighttime chorus. It is like hearing your name in a noisy room. Their sensory world is layered. Airborne sound, waterborne vibration, and ground tremors can all become meaningful signals. When a frog pauses and seems still, it may be listening with far more than ears alone. Through the power of vocal resonance, a single frog can transform a quiet marsh into a booming nighttime amphitheater. If you have ever heard a frog at night and wondered how something so small can sound so bold, the answer is clever anatomy. Many male frogs use a vocal sac that inflates like a balloon. As air moves back and forth, the sac acts as a resonator, shaping and amplifying the call, without the frog needing to waste extra energy on constant new breaths. The sound can travel across water, through reeds, and into windows that are still open to the evening air. In some places, a single caller can seem like a crowd because echoes bounce off surfaces and overlap with other noises. The call is not just noise. It is a message with purpose, aimed at being noticed. The sac is part instrument and part advertisement board. It turns a small body into a nighttime broadcast station, sending information across surprising distances until the dark finally fades. Some frogs live high in mountains, where nights freeze year-round. High in the mountains, cold is not a season. It is a daily reality. Some frogs survive in places where thin air and sharp temperature swings would overwhelm most amphibians. In those habitats, daylight can bring brief warmth, then darkness can snap the world back toward ice. High-altitude frogs have mastered the art of biological timing, seizing the brief windows of warmth in a frozen world. They may feed and move during short windows, then shelter in crevices, under stones, or in insulated mud. Their bodies must cope with slow chemistry in the cold, and their breeding must fit into narrow opportunities when water is available and not locked away as ice. Living up there also means strong sunlight and fast weather changes. It is an extreme stage for a creature many people associate with warm ponds. These frogs prove that amphibian life can climb into thin, harsh places and still find a way to endure. Other frogs thrive in deserts by waiting underground for sudden rains. A desert can look empty, yet the ground can be holding a secret heartbeat. Some frogs survive long, dry stretches by disappearing beneath the surface, sealed away in cool soil where moisture lasts longer. They can remain inactive for months, sometimes for years, conserving energy as if time itself has slowed. Then rain arrives. The desert changes in hours. Shallow pools form, insects rise, and the hidden frogs wake and rush upward. In some places, their breeding happens so quickly it feels like a natural emergency drill. Calling, mating, and egg-laying can unfold in a short burst before water vanishes again. For a frog, this is not a gamble. It is a strategy polished by harsh landscapes. These desert specialists show that survival is not always about constant movement. Sometimes it is about patience, timing, and the ability to spring into action when the world briefly offers water. In a defiant twist of evolution, some species bypass the tadpole stage entirely, emerging from the egg fully formed. Not every frog begins life as a swimming tadpole. Some species take a different route, building the whole frog body inside the egg. Instead of hatching into open water, a tiny froglet emerges, already shaped for land. This strategy can be useful in places where streams are dangerous, ponds dry out, or predators fill the water. It is also a quieter beginning. A clutch hidden in damp soil or tucked under leaves can develop out of sight. protected by the humidity of the forest floor. Inside each egg, tissues reorganize, and limbs form in a sheltered world. When the shell finally gives way, the froglet steps into life, ready to hop and hunt small prey. It is an example of how frogs tailor their life stories to their surroundings. They are not locked into one script. Evolution has written multiple beginnings for the same kind of animal. Certain frogs brood their eggs in their mouths for weeks. There are frogs that treat parenthood like a full-time mission. In some species, the adult takes eggs into the mouth after they are laid, keeping them safe through a vulnerable stage. Imagine the restraint that requires. Feeding becomes difficult, and every movement must avoid harming the developing young, yet the payoff is enormous. Eggs carried this way are sheltered from drying out, from sudden temperature swings, and from many predators that patrol shallow water. As days pass, the young continue developing in a warm, protected space. When the time is right, the parent releases them, and the next stage of life begins. This kind of care also changes how we think about frogs. They are often seen as creatures that scatter eggs and leave. Mouth brooding flips that idea. It shows attention, risk, and a surprising tenderness, all wrapped into a strategy for survival. A few frogs build foam nests that protect eggs from drying. Some frogs make nurseries out of bubbles. During breeding, a pair can whip mucus and air into a thick foam, creating a floating or ground-level nest that looks like froth from a tiny storm. Inside that foam, eggs stay moist, even when the air is dry or the water level shifts. The foam can also push in the eggs from heat and reduce the reach of some small predators. Over time, the structure slowly breaks down, and the hatchlings slip into water below or into a safer wet space nearby. It is an engineering solution built from the body itself, using simple materials to solve a big problem. This kind of nest shows how inventive frogs can be. They do not need sticks or leaves to build protection. They turn air and mucus into a temporary shelter, timed perfectly for a fragile stage of life. The glass frog offers a literal window into life, its translucent skin revealing the rhythmic beating of its heart. In certain cloud forests of Central and South America, a small green frog can look almost ordinary from above. Then it shifts, and the underside tells a different story. The belly skin can be so clear that you can glimpse a beating heart, looping intestines, and the outline of a liver. This is not a trick for humans. It is camouflage for life on leaves. When a predator looks up from below, the frog's outline can blur into the leaf's brightness and shadow. Some glass frogs even sleep belly down on leaves over streams, as if the leaf itself is the only blanket they need. Scientists have found that at least some species can tuck away red blood cells in the liver while resting, which can make them appear even more transparent. It is nature turning a body into a living window. Tree frogs cling with toe pads that use moisture and micro-ridges. A tree frog can climb a smooth leaf, a slick branch, and sometimes a window, and it does not need claws to do it. The secret lives in the toe pads. Under a microscope, those pads are not flat. They are covered in tiny structures that increase contact and help control a thin film of moisture. That moisture becomes part of the grip, creating adhesion that works even on surfaces that look impossibly smooth. The frog adjusts pressure and angle with each step, testing and retesting its hold like a careful climber. In a wet forest canopy, this is the difference between feeding safely and falling into danger. It also opens up an entire vertical world. A pond is no longer the whole habitat. Leaves, trunks, and high branches become roads and hunting grounds. The next time you see a frog perched above eye level, remember it is using physics with every touch. Burrowing frogs have hard spades on their feet for digging. When the ground begins to dry, some frogs do not search for a new pond. They vanish. Burrowing species often have hardened structures on their hind feet that work like digging tools, sometimes called spades. With rapid kicks, the frog backs itself into soil, sinking down until it finds cooler, moister layers below. Down there, it can wait out harsh conditions that would dehydrate an exposed body. This is not just hiding, it is a lifestyle built around the underground. The frog's shape, skin, and behavior all support a rhythm of disappearing and reappearing when the surface world becomes livable again. To an observer, it can feel like the frog has teleported. One moment, it is on open ground. The next, the spot is empty. In reality, it has simply taken the secret door that soil provides, using its own feet as shovels. Many frogs can jump far because their legs store springy tendon energy. A frog's jump can look like pure muscle, but a lot of the power comes from elastic storage. Tendons and stretchy tissues in the legs can load energy like a drawn bow. The frog holds and compresses tension while crouching, then abruptly releases it to propel its body forward. This allows a small animal to produce a big leap without needing endless raw strength. In a single, decisive move, it can be used to strike toward prey, avoid predators, and cross gaps. Additionally, the jump is remarkably controlled. The frog can change angle, adjust body posture mid-flight, and land with a plan rather than a crash. In the wild, a good jump is often the difference between being seen and being gone. That is why frog legs are not just long. They are made to convert stored energy into instant distance, much like natural springs. Some frogs walk instead of hopping, using a careful stepping gait. Not all frogs move like a bouncing rubber ball, despite the fact that hopping is well known. Some species walk, placing one foot and then the next, with a steady, deliberate rhythm. This can be useful in tight spaces, where a jump would overshoot a target, or on narrow branches, where balance matters more than speed. When a frog is stalking prey up close, walking also helps, because a quick hop can alert an insect before the strike. In certain frogs, the body looks almost relaxed during this movement, with hips and shoulders shifting as if the animal is testing each step for stability. Watching it can feel oddly familiar, like seeing a tiny creature borrow a mammal's style for a moment. It serves as a reminder that frogs can travel in a variety of ways. The frog body plan is flexible. Even something as iconic as the hop is optional when the environment rewards patience and control. A frog's skin is a living laboratory, producing potent antimicrobial compounds that guard against a microscopic world of infection. The skin of frogs is more than just a surface. It is a chemical shield. Many species produce compounds in their skin, secretions that can slow or stop the growth of microbes. This matters because frogs live in damp places where bacteria and fungi thrive. A moist body in a wet habitat is an invitation to infection, so chemical defense becomes a daily necessity. These skin compounds have been the subject of decades of research, in part because they offer fresh perspectives on managing dangerous microorganisms. In the frog's world, the goal is simple: keep the skin healthy enough to breathe through, to absorb water, and to stay resilient against scratches and parasites. The chemistry can vary from species to species, which means a rainforest hillside may hold a library of different solutions. It is a quiet form of innovation, written into the skin of animals that most people only notice when they hear a call at night. Certain frogs have the ability to grow back damaged toes and occasionally entire limbs. If a frog loses a toe or suffers an injury that would be permanent for many animals, the story is not always finished. Some frogs can regrow damaged toes, and in certain cases, they can restore more complex structures. This ability is not unlimited, and it varies widely across species and life stages. But when it happens, it feels like nature revealing a hidden repair mode. Regeneration requires cells to coordinate, rebuild tissues, and reconnect function, all while the animal continues living in a world full of risks. For a frog, this can mean recovering climbing ability, improving swimming control, or simply restoring balance after a close escape. Scientists study regeneration because it can hint at how bodies decide what to rebuild and how far to go. In the frog's everyday life, it is a practical advantage. A narrow escape does not always have to become a lifelong handicap. Sometimes the body can rewrite what was lost. Certain frogs can slow their metabolism to survive long droughts. When water disappears, a frog's greatest danger is not hunger, it is drying out. In response, some species go into a low-energy state in which their metabolism slows down, their movement ceases, and their bodies use fuel cautiously. In effect, the frog makes itself wait. Buried in soil or tucked into a protected pocket, it can ride out weeks or months that would otherwise be fatal. The body becomes a savings account, spending as little as possible until conditions improve. This strategy can be paired with a cocoon of shed skin in some species, which helps reduce water loss and adds another layer of protection. Then, when rain finally returns, the frog can revive and rejoin the surface world with startling speed. It is a survival pattern built for climates that swing between abundance and scarcity. The frog does not need constant comfort. It needs timing. It requires perseverance. It needs the ability to turn down life's volume until the environment turns it back up. From diligent grazers to stealthy filter feeders, tadpoles play a diverse and vital role in the aquatic ecosystem. Or even scavengers. The pond will surprise you if you imagine all the tadpoles to be tiny vegetarians with wiggly tails. Some species have young that spend their days scraping algae off of surfaces like tiny lawnmowers. Others transform a murky soup into food by filtering out tiny particles from the water. With mouths and behaviors appropriate for pursuing smaller animals, some are designed for hunting. A few will scavenge, cleaning up what the pond offers after storms or die-offs. It's not a fun detail, this variety. It alters a pond's overall functioning. It affects water clarity, algae growth, and which insects thrive. It also implies that different tadpoles can coexist in the same body of water without engaging in direct competition. Numerous feeding strategies, each influenced by local conditions, can be implemented simultaneously in a single pond. There is more than one type of tadpole. They are a whole set of lifestyles. Some tadpoles form schools, which can reduce each individual's risk. In still water, being alone can be dangerous. Some tadpoles respond by gathering into tight, coordinated groups that move as one shifting shape. A predator that lunges at a school has trouble targeting a single body because the mass of tails and shadows keeps changing. Any one tadpole is more likely to be overlooked in that confusion. Foraging can also be aided by schooling. A moving group can stir up food particles and uncover algae on surfaces, which makes feeding easier for everyone. Even an early warning system can be used by the group. When one tadpole bolts, the rest can copy the motion in an instant. To a human watching from above, it can look like a dark cloud that suddenly turns and pours across the pond. It is a simple idea, yet it is powerful. Even in the early stages of a frog's life, rhythm and unity can provide safety. The keratin mouthparts of many tadpoles are used to scrape algae off of rocks. Look closely at a tadpole clinging to a stone in a stream, and you may see a mouth built like a small tool. Many species have tough, keratin-based mouthparts, sometimes arranged like tiny tooth rows. They use them to rasp algae and biofilm from rocks, wood, and plant stems. In fast water, this matters. Food moves around. The tadpole must cling on and gather what grows on solid surfaces, because the current is constantly flowing. The stream itself may be shaped by this scraping life. Tadpoles can affect the amount of algae that accumulates through grazing, which has an impact on oxygen levels and the microscopic organisms that inhabit that slimy layer. Tadpoles are often thought of as defenseless infants, and yet here they are, working like underwater gardeners, steadily removing a living carpet from the stream bed while holding onto stones and blocking the flow. Certain tadpoles eat mosquito larvae, which can reduce local biting pressure. In warm months, mosquitoes turn still water into a nursery. Yet, in some ponds, mosquito larvae are not safe. Certain tadpoles will eat them, snapping up the wriggling bodies near the surface. This does not imply that frogs are an easy fix for all mosquito issues. as ecology is never that neat. Still, it shows how young frogs can influence the insects that shape our summers. When tadpoles are abundant, they can add real predation pressure in small pools and ditches where larvae concentrate. This also alters your perspective of a pond. It is not just a place where mosquitoes breed. Numerous species interact, compete, and hunt one another there. A tadpole that eats larvae is doing more than feeding. The distribution of those who prosper and those who struggle is changing as a result. One mouthful at a time, it can influence the experiences of the animals around it, including us, even before it turns into a frog. When food is in short supply, some species of tadpoles become cannibalistic. A shrinking pond can become a harsh classroom. Some tadpoles adopt an unexpected tactic when competition increases and algae disappears. They have the ability to attack and consume other tadpoles, including their own. This behavior is not cruelty. It is survival under stress and can be brought on by hunger and crowding. A tadpole that gains extra protein can grow faster, which matters when water is evaporating and time is running out. Stronger jaws are a good fit for this hazardous diet, and in some species, individuals even develop different body forms based on environmental factors. The pond turns into a setting where behavior is instantly shaped by the surroundings. It is also a reminder that nature does not promise comfort. Tadpoles inhabit environments where resources can abruptly run out. Some people react to that by drastically changing their behavior. The same animal that once grazed peacefully can become a predator because scarcity rewrites the rules. Tadpoles are able to detect chemical cues that indicate the presence of predators. A tadpole can sense impending danger without having to see a predator. Many can detect chemicals in the water that hint at danger, including scents released by predators or alarm cues from injured peers. That knowledge has the power to quickly alter behavior. A tadpole may freeze, sink, or stop feeding even if the water looks calm. Some will choose to spend their time in deeper or more densely vegetated areas. It's like reading invisible headlines in the pond when you have this chemical awareness. It helps because water carries information in ways air does not. A ripple fades quickly, yet molecules can linger and drift. For a tiny creature with weak defenses, this early warning system may mean the difference between survival and extinction. Additionally, it gives pond life more depth. Beneath the surface, there is a constant flow of signals. Tadpoles are listening with their skin and senses, tracking threats through chemistry rather than through sight alone. Some tadpoles grow larger tails when danger is high, improving escape. Fear can mold the body in certain ponds. Tadpoles can grow deeper or more muscular tails to help them run away with stronger bursts when they sense a higher risk from predators. This is not a deliberate decision. It is a biological response, guided by cues in the water that signal danger. The payoff is speed, yet there is a cost. Building extra tail tissue requires energy that could have gone into overall growth or faster development. Nevertheless, survival takes precedence in a pond full of hunters. The result is a living example of flexibility. The same species can produce different body shapes depending on the threats around it. It is a kind of emergency design built into development. Two tadpoles from different ponds may have different proportions, swimming styles, and chances of surviving if you were to compare them. Risk is not only a feeling, it can occasionally turn into anatomy. When plants are transformed into insects, the gut is reorganized. Legs and lungs are just two aspects of the transition from tadpole to frog. The digestive system changes inside as well. A tadpole that spends its days grazing algae needs a gut suited to processing plant material, which can be bulky and slow to digest. The gut no longer requires the same configuration as the animal switches to a diet of insects and other small prey. Tissues remodel, and the digestive tract adapts to a new type of food during metamorphosis. It is like swapping out the kitchen for a new cuisine. This internal shift helps explain why metamorphosis can be such an intense period. The body is not adding features on top of the old plan. It is rebuilding systems to suit a different lifestyle. The tadpole was never able to hunt or digest like the young frog can now. It's not a costume change. It is a complete change in how the animal fuels its life. The tail of a tadpole is absorbed and recycled as fuel during metamorphosis. The disappearing tail is one of the strangest parts of a frog's transformation. It does not simply fall off. The body breaks it down and reuses the materials. The demanding changes that are taking place at the same time can be powered by proteins and other resources that are stored in that tail and can be redirected to support growth elsewhere. This recycling is both essential and effective. Metamorphosis can reduce feeding for a period because the mouth and gut are changing. Internal reserves are necessary for the animal to survive. The tail becomes a built-in pantry, and then it becomes raw material for the new body. If you could watch the process in slow motion, it would look like the tadpole is carefully packing up one life to build another. It serves as a reminder that progress can be both significant and useful. Biology wastes very little, even in a pond. Frog development is guided by thyroid hormones, acting like a body-wide switch. Behind the visible transformation is a quiet chemical conductor. Many of the changes that transform a tadpole into a frog are regulated by thyroid hormones, which also help time the development of limbs, the reshaping of organs, and the movement of tissues throughout the body. One change at a time is not the case. It is a synchronized sequence, and hormones help keep it from becoming chaos. If hormone levels rise too early or too late, the results can be harmful because the body depends on the right order. This makes development both powerful and sensitive. It is one reason environmental conditions matter so much in a tadpole's world. Temperature, nutrition, and water quality can influence how smoothly the process unfolds. Thinking about this can make metamorphosis feel even more astonishing. A whole body responds to chemical signals, like a city changing its layout according to a planned schedule. Tiny molecules set the pace, and the animal follows, step by step, toward a new way of living. Frogs are cold-blooded, so their activity depends strongly on temperature. A frog's energy is closely tied to the warmth around it. In cool conditions, muscles work more slowly, reaction times stretch, and movement becomes cautious. In warmth, the same frog can become quick, hungry, and alert. This link shapes everything about frog life. It influences when they hunt, when they call, and even where they choose to rest during the day. A sunny rock can become a charging station. A shaded puddle can become a refuge from overheating. Temperature also shapes development, which can affect how fast young frogs reach the next stage of life. Because frogs do not generate their own steady internal heat, they must read the landscape like a map of safe zones and dangerous extremes. This makes them sensitive to changing weather patterns and to shifting seasons. It is not just comfort, it is capability. For a frog, warmth can mean speed and survival. Cold can mean stillness and vulnerability. Their bodies are tuned to the world's thermometer. A frog's heart has 3 chambers, blending blood in a unique way. Inside a frog's chest, the heart runs on a plan that is different from ours. Instead of 4 chambers, there are 3, 2 upper chambers and 1 lower chamber. This design can allow some mixing of oxygen-rich and oxygen-poor blood. Yet it also supports flexible circulation that suits a creature living between water and land. A frog may need one pattern of blood flow while breathing air, and another while exchanging gases through skin in water. The harp's structure helps make that shifting lifestyle possible. It is not a flawed version of a mammal heart. It is a heart built for amphibious reality. This can be especially useful during diving or resting, when the frog's breathing patterns change and the body needs to prioritize different tissues. Thinking about that heartbeat can change how you see a frog sitting still. Beneath the quiet skin is a circulation system designed for a life that does not choose one world, it uses both. Some frogs practice explosive breeding, where whole ponds erupt with activity. In certain locations, A pond may appear empty for weeks before everything occurs at once. After the right rain, frogs may converge in a sudden rush, turning one small stretch of water into a crowded, noisy gathering. The timing is the point. By breathing all together, they can overwhelm predators with sheer numbers, so more eggs and young slip through the danger. It also implies that adults don't have to remain exposed for very long. They arrive, call, mate, and depart in a short window, sometimes in a single night. For anyone who stumbles across it, can feel like nature flipped a switch. The air trembles with conflicting voices, and the shoreline is alive with movement. It serves as a reminder that frog life is frequently dictated by patience and the weather. When the moment arrives, they spend it fast. Frogs can deposit their eggs in small rain pools, tree holes, or leaf cups. A large pond is not necessary for a frog to begin a new life. In forests, water collects in surprising places, and frogs have learned to use them. A tiny cup of rain can fit inside a leaf. A tree hollow can be turned into a tiny pond. A palm or a fallen branch can trap enough water for a clutch to begin. Because they are inaccessible to big fish and other aquatic predators, these tiny nurseries can provide protection, yet they also demand precision. The water may warm quickly, it may evaporate, and it may hold only limited food. That is why choosing the right pocket matters, and why some species return to the same kinds of hidden containers again and again. It is an alternative perspective on frog habitats. A forest is not just land with streams running through it. It is a web of little reservoirs scattered like secret rooms. Certain frogs lay eggs on land, then rain washes hatchlings to water. For some frogs, the safest beginning is not in open water. It is on land, tucked into damp places where fish and many aquatic hunters cannot reach. Eggs can be laid on muddy banks, in damp leaf litter, or on overhanging vegetation close to streams. The decision prepares for a deft handoff. When rain arrives, water carries the hatchlings down into pools and channels where they can continue developing. It is a tactic based on timing and faith in the weather. The young might never make it to safety if the eggs are placed too far from the water. Put them too close, and flooding may sweep them away too soon. When the conditions are right, rain becomes transportation, and land becomes a cradle. This method demonstrates how frogs use entire landscapes, rather than just ponds, to address the challenge of bringing new life into a dangerous environment. In order to prevent fungus, some species guard their eggs by fanning them with their legs. Eggs seem still, yet they are busy, living bundles that need oxygen and stable conditions. In some frog species, a parent stays close and actively protects them. The adult may position the body over the clutch and use leg movements to circulate water or air around the eggs. By keeping the embryos supplied with fresh oxygen, this fanning can help inhibit the growth of fungi. It also deters small predators that might peek at the clutch when no one is watching. The cost is real. Guarding ties the parent to one place, and it can reduce feeding and increase exposure. However, that attention can mean the difference between a successful hatch and a silent death for eggs that might otherwise fail. It changes the story many people tell about frogs. Not all frogs scatter their eggs and disappear. A few remain. A little labor. Some invest in the fragile beginning, one careful movement at a time. A few frogs give live birth, with embryos developing inside the mother. Some species take a more personal route, but the majority of frogs start out as eggs released into the world. In these situations, instead of leaving eggs behind, the mother gives birth to live offspring after the young develop inside her. This approach can protect developing young from drying out, from sudden cold snaps, and from many predators that hunt eggs in shallow water. It also implies that the mother bears the direct and demanding burden of reproduction. She must balance her own survival with the needs of the developing young through weeks or months of internal growth. For listeners, it can be a startling twist. Although this pattern is more frequently connected to mammals, frogs feel familiar. It serves as yet another reminder that amphibians have multiple reproductive strategies. They have experimented across evolution with many solutions, and live birth is one of the most dramatic. As if they were tiny territorial owners, some males construct and protect nesting sites. A good nesting place is valuable enough to be claimed by some frog species. A male may treat a protected water edge, a shallow depression, or a patch of mud like property. He calls from there, he patrols it, and he may drive away rivals that try to move in. The site can matter because it offers better oxygen, better shelter, or a safer place for eggs to develop. Sometimes the nest itself is shaped or cleared, which makes the spot more than a location. It becomes a prepared space. Breeding becomes more than just singing and hoping as a result. It becomes strategy and defense. The nest can be used as evidence that the male has worked hard and is capable of holding a resource when a female arrives. It is a small-scale version of a familiar pattern across nature. Build something worth having, then protect it long enough for it to matter. Some frogs feed their developing tadpoles unfertilized eggs. Some frog nurseries are too small or too isolated to provide enough food, so a parent brings the food. Some species raise their tadpoles in small pools with little algae and few insects. To keep them growing, a parent returns and provides unfertilized eggs that the tadpoles can eat. This is not a mistake in reproduction. It's a planned meal. The parent is converting energy into a portable, safe form that can be delivered directly to the young. It also allows the tadpoles to stay in protected places that many predators cannot access. Time and effort are the trade-offs. The parent must revisit the nursery repeatedly, and each trip carries risk. Yet the payoff is a better chance that the young reach the stage where they can leave the nursery behind. It is care that looks almost like provisioning in birds, adapted to an amphibian world of water pockets and hidden cradles. Some frogs raise tadpoles in bromeliads, one little nursery at a time. Some frogs use the tiny pools of water that a bromeliad can hold between its leaves as private nurseries. Instead of trusting a big pond crowded with hungry mouths, a parent uses these plant reservoirs as scattered childcare stations. Because each nursery is small, covered, and raised off the ground, fewer predators may be able to access it. In order to check the water levels and place the young in the best conditions, the parent may climb from plant to plant. The forest canopy turns into a system of small ponds, each of which is a distinct world, with its own food, oxygen, and temperature constraints. Raising tadpoles this way takes planning, because each pool can support only so much life. This explains why the strategy seems so methodical. By dispersing young throughout the living architecture of the forest, it transforms a plant into a habitat, and the parent into a cautious resource manager. A handful of frogs use streams so fast, the eggs must cling tightly. Although they are lovely, fast streams are harsh. For frogs that breed in rushing water, the current can tear eggs away in moments. Because of this, some species that breed in streams rely on eggs that adhere firmly to rocks or are deposited in protected areas where flow is lessened. The location matters as much as the egg itself. A rock face behind a small barrier can become a calmer microhabitat, even while the main stream roars beside it. The reward for choosing swift water is often cleaner, more oxygen-rich conditions, and fewer of the predators that thrive in still ponds. Yet the risks are constant. A flood can scour the streambed. Eggs can be peeled away by a powerful surge. Here, breeding is a precision test. It is not just about making eggs. It involves securing a future to a surface that is constantly moving. Some frog eggs have layers of jelly that block damaging sunlight in a world where water is constantly flowing. Frog eggs are not just round dots in water. Their jelly coats can be complex, layered, and protective. In shallow pools and sunlit puddles, intense sunlight can damage developing embryos, so some eggs include jelly that helps filter harmful rays. This matters because many frogs breed in exposed places where shade is limited and where the water can warm quickly under open sky. The jelly can also help with moisture balance and physical cushioning, yet the light protection is a striking detail because it turns the egg into a kind of natural sunscreen package. Each embryo develops inside a small, clear world that is engineered for survival before the animal has any way to move away from danger. When you see frogs spawn, it is easy to think it is simple. Up close, it is a designed environment. The egg coat is doing work, managing light and chemistry, so development can proceed even in bright, risky water. Many frogs are ambush predators, striking in a blink when prey moves. A component of the strategy is stillness. Many frogs don't pursue, they bide their time. A frog may perch on a wet log or at the edge of a pond, keeping an eye out for even the smallest movement. Since quick prey is frequently easiest to spot when it shifts, movement is the most important trigger. Then the strike happens fast enough to feel unreal. The body launches, the mouth opens, and the prey is gone before the scene looks changed. This method of hunting conserves energy, which is important for an animal that depends on moisture and warmth for survival. Frogs are crucial in areas where insects proliferate following rainfall. A quiet frog can become a nightly checkpoint, turning a stream of flying and crawling creatures into dinner. It can appear passive to wait. In a frog, waiting is aim, timing, and patience made sharp. Some frogs hunt ants, termites, or beetles, shaping insect communities. In many habitats, ants and termites are like the background machinery of the world. They quickly proliferate, build, tunnel, and harvest. Focusing on these industrious insects is how some frogs earn a living, and this decision can have repercussions. The species of ants that predominate in a patch of ground can be affected when a frog targets ants. The rate at which wood and leaf litter are processed may be impacted when termites are the target. Beetles add another layer, because some are plant eaters and some are predators themselves. A frog that eats beetles can shift who gets to feast on leaves and who gets to hunt other insects. This is not dramatic like a lion on a savanna, yet it is powerful in a smaller world. Frogs are often overlooked as insect hunters, but their appetites can quietly reshape the busy societies under your feet. Some frogs use their hands to stuff food into their mouths. Not all frogs rely solely on their jaw and tongue. Some will actively use their front feet to push food into their mouth, especially when prey is large, awkward, or still struggling. It can look almost like a person helping a bite along. The frog pins the prey, adjusts its grip, and nudges it into place so the swallow can succeed. This behavior is striking because it feels deliberate and almost clever, even though it is guided by instinct and experience. It also alludes to the difficulty of swallowing whole. A slippery creature, a long insect, or a spiny beetle may become lodged at the mouth's edge. Hands are used as tools to solve the issue. This minor detail can alter your perception of a frog's body. These front feet are used for more than just climbing and landing. They can occasionally be a component of the feeding apparatus, converting a fast grab into a complete meal. Frogs help control pests, but they also feed birds, fish, and snakes. Ecosystems remain stable, in part because frogs are both hunters and hunted. Frogs can lessen the number of crop nibblers and biting pests by consuming insects. Yet frogs are also a crucial food source for many animals that people do notice, including herons, kingfishers, trout, bass, garter snakes, and even mammals near wetlands. That means frog populations can influence the success of predators up and down the food chain. When frog numbers rise, more young birds may fledge, and more fish may grow quickly. When frog numbers drop, those same predators may struggle or switch prey, creating new pressure elsewhere. This double role makes frogs feel like living connectors, transferring energy from swarming insects into larger bodies that roam farther and shape bigger territories. A frog on a lily pad is not only a single creature, it is a moving packet of calories, poised to travel through the ecosystem in two directions. Frogs are key links in food webs, moving energy between land and water. Most animals only inhabit one realm. Frogs do not. They can migrate with the seasons and frequently start their lives in the water before spending a portion of their adult lives on land. That motion carries energy with it. Aquatic resources are transformed into growing tissue by a tadpole feeding in a pond. Later, a young frog hops onto land and becomes prey for land predators, or it eats land insects and returns to the water to breed. In that way, frogs act like shuttles between ecosystems that might otherwise be more separate. Nutrients and calories move with them. Even their waste can fertilize the places they visit. This is important in areas like streams, wetlands, and the edges of forests, where boundaries are hazy and everything influences everything else. Frogs don't only live in ponds, they are couriers. They maintain the flow of exchange in both directions and aid in connecting a watery world to a leafy one. A pond with many frog species often supports more diverse predators too. A pond that hosts many kinds of frogs tends to offer a wider menu across seasons and sizes. Some species call and breed early, others later. Some produce small young, others produce larger young. That variety can support a larger cast of predators because different hunters specialize in different opportunities. A dragonfly nymph may target one size class. A fish may prefer another. A wading bird may arrive when adults gather at the edge. Diversity in frogs can create diversity in timing, and timing is food. This can make a pond feel more alive overall, with more interactions and more niche roles being filled. It's similar to a theater where numerous shows are planned instead of just one brief performance. It also implies that safeguarding the diversity of frogs can contribute to the protection of the larger community, which includes predators that people respect and are aware of. The foundation of a more intricate food web is also audible when you hear distinct calls coming from the same pond. When frogs vanish, insect outbreaks and algae shifts can follow quickly. Frogs sit in the middle of many relationships, so their absence can change the balance faster than people expect. If frogs decline, insects that were once eaten may increase, and that can affect crops, gardens, and human comfort near wetlands. In water, the loss of tadpoles can also matter, because many tadpoles graze algae or process particles. When that pressure disappears, algal growth and water clarity can shift, which can change oxygen levels and stress other species. Predators that relied on frogs may switch prey, adding new pressure on insects, fish, or small animals that were not previously targeted as heavily. If you only examine one species at a time, the outcome may be a confusing cascade. Although they actively contribute to maintaining the balance of their habitats, frogs are frequently referred to as indicators of environmental health. When they vanish, the ecosystem does not simply become quieter, it can become reorganized. Male frogs often sing to attract mates, and each species has a signature call. On a warm night near water, the air can feel stitched together by sound. A male frog can be located in the dark by calling. Each species has its own pattern, like an audio name tag, so the right partners can locate each other even when many voices overlap. Some calls are short and repeated, others are long and rolling, and some come in sharp bursts that sound almost mechanical. The call can carry information about size and stamina, because producing it costs energy. In crowded places, a male may choose a calling spot that helps the sound travel, such as a reed, a rock edge, or a shallow pool. For the listener, it can seem like background noise. For frogs, it is navigation, courtship, and identity, all at once. Some frog calls are ultrasonic, too high for human ears. Not all frog voices live in the range we can hear. Some species produce calls that reach into ultrasonic territory, which means they can sound almost silent to people standing nearby. That high pitch can sound urgent and clear to another frog. Why make a call that people are unable to follow? One advantage is a quieter channel, because fewer animals compete at those frequencies. Another is privacy. The caller may lower risk while still getting to a mate if a predator misses the signal. Additionally, High-frequency sound behaves differently in the presence of leaves and branches, which can affect how far it travels and how it appears to come from. The result is a hidden soundscape layered over the one we notice. You can stand beside a stream and think the night is calm, while an invisible concert is happening above your hearing. It is a reminder that nature is not only what we perceive, it is also what we miss. Many frogs use a vocal sac as a resonator, not just a balloon. When a frog calls, the inflated throat can look like a simple bubble of air. It is more impressive than that. The vocal sac acts like a resonator, shaping the sound and boosting it, so the call carries farther with less effort. Air moves back and forth between lungs and sac, which means the frog does not need to take a fresh breath for every note. That recycling makes long calling bouts possible, even for a small body. Additionally, the sac can aid in sound aim. Depending on how the frog is positioned, the call can project across water or through reeds, like a speaker turned toward an audience. In certain species, the size and color of the sac provide a visual cue that corresponds with the voice, which can be significant up close. It is a multi-purpose instrument built into the frog's anatomy. The next time you hear a call, imagine the throat as a tuned chamber, not just an inflatable pouch. In certain species, females select males whose sounds have the most consistent rhythm. A frog chorus is not random noise. It can be a contest of timing. In certain species, females show preferences for calls with steady rhythm and reliable spacing, as if the beat itself carries meaning. A man's endurance, coordination, and capacity to continue calling through disruptions can all be inferred from consistency. It can also help a female track a single voice in a crowded sound field, because a predictable pattern is easier to follow. That choice can shape evolution over generations. Males that hold the rhythm get more chances to pass on their traits, while messy callers may be ignored even if they are close by. On nights when many males call, the difference between being chosen and being overlooked can be a subtle change in tempo. It is courtship measured in milliseconds, played out on pond edges. It may sound like simple croaking to humans. For frogs, it can be music with rules. Rival males may wrestle, shove, or call over each other all night. Until you hear the tension beneath the sound, a breeding pond may seem serene. Space and attention become valuable when a large number of men congregate, and some will fight for both. They may push, grapple, or try to dislodge a rival from a prime calling spot. The fight is typically acoustic. In an attempt to obfuscate a rival's message, a male may call faster, louder, or time his notes to overlap another male's signal. Some species even form small clusters where neighbors constantly adjust their calls, like a living volume war. The conflict can last for hours because the opportunity window is short and the stakes are high. If a male loses a position near the best water, he may lose the night. He might draw a partner if he holds it. It is a reminder that frog life is not only hiding and hopping. It is also rivalry, strategy, and endurance, performed in the dark with voices and bodies. Certain frogs have the ability to use the environment to amplify their voices. In certain habitats, a frog's call can seem to come from nowhere or from a direction that feels wrong. Part of that is the landscape. Water surfaces reflect sound. Dense vegetation absorbs some frequencies and bounces others. Rock walls and stream banks can create echoes that blur the true source. A frog can take advantage of this by choosing a calling position that makes the sound travel, such as a hollow log, a bank curve, or a pocket of reeds that acts like a funnel. The call may seem louder than the animal to the listener, as though the night itself is speaking. This can confuse predators and also draw in mates from a wider area. It is not a magic trick. It has to do with acoustics. The frog is using its surroundings as a tool, using ravines and pond edges as organic amplifiers. When you hear a call and cannot locate it, you are experiencing the same puzzle other animals face. Some frogs use the soil as a natural speaker when they call from underground. Some frogs perform their songs from beneath the surface, with only a small opening to the outside world. It sounds strange, yet it can be effective. Soil and burrow walls can filter the call, shaping it into a lower, booming quality that carries in a different way than an open-air voice. Calling underground can also provide safety. To lessen the likelihood of being caught by a nighttime predator, a frog can advertise without sitting completely exposed on the surface. In dry regions, burrows can keep moisture close, so the frog can call without drying out as quickly. The burrow becomes both shelter and stage. The sound may appear to a human ear to be emanating from the earth itself, akin to a secret engine buried beneath the soil. This behavior demonstrates how adaptable frogs can be when communicating. They do not only sing from lily pads, they can still reach the audience they require by converting a tumble into a sound booth. A few frogs make ticking sounds without opening their mouths much. Not every frog call is a classic croak. Certain species make sharp taps or clicks that sound less like voices and more like tiny stones striking. The frog can communicate while remaining less noticeable by producing these sounds with very little mouth movement. Because a sudden percussion sound is easy to notice in a crowded environment, clicks can also cut through background noise. The effect can be surprising. The frog appears to be nearly motionless, despite your expectations of a loud throat and an open mouth. However, the sound persists, steady and intent. Clicks can be used to announce presence in a particular area of habitat, attract mates, or create space between competitors. They add variety to the nighttime soundscape, proving that frog communication is not one simple style repeated worldwide. It is a toolbox. A booming note is used by some frogs. Others use a fast click, and both can be equally effective. Some frogs call from water, creating ripples that can reveal their location. Calling from the water can give a frog quick escape routes, because a dive is only a flick away. Yet it comes with a risk that is easy to overlook. When a frog inflates a vocal sac at the surface, it can disturb the water and send out ripples. For predators that hunt by sight or vibration, those ripples may serve as a visual beacon. A pattern on the surface can indicate the caller's precise location even in low light. That means the frog must balance two needs, being heard and staying alive. Some will call from partial cover, nestled among plants or near edges, where surface movement looks less obvious. Some people might time calls in short bursts before becoming motionless, causing the ripples to fade before the next message. It is communication with consequences. There is a fee for the call. It can announce more than romance. It can announce location. Yet frogs keep doing it because the chance to be found by a mate is worth the danger. Frogs can tell direction partly by timing differences between their ears. In a dark pond-edge chorus, finding a single caller can feel impossible. Frogs manage it by using subtle timing cues. A sound reaches one ear, a tiny fraction of a moment before the other, and the brain can use that difference to estimate direction. Despite the small size of the head, the system is sensitive enough to direct approach, turning, and hopping. Finding your way also helps you stay out of trouble. Before the threat is even apparent, a frog can orient itself away from abrupt splashes or footsteps. In dense vegetation, this skill becomes crucial because sightlines are short and the night is crowded with movement. Additionally, advantageous to certain frogs is the way their ear structures attach to the head, which can improve the contrast between inputs from the left and the right. As a result, there is a type of nighttime navigation that uses sound just as much as sight. Imagine that each frog creates a mental map of voices surrounding it when you hear a chorus, using minute variations in arrival times to determine where to go. Worldwide, many frog populations are threatened by habitat loss and climate stress. The delicate conditions that frogs rely on are being squeezed from many directions. Wetlands are filled or drained. The edges of forests are trimmed back. Streams are redirected. Even small changes can matter, because many frogs rely on specific breeding sites and specific moisture levels. Another layer is added by climate stress. Unusual rainfall can cause breeding seasons to be out of sync with food and safety, and heat waves can dry out shallow pools before young have finished developing. Some regions experience more severe storms, while others experience droughts that last longer than the frogs are adapted to. The hard part is that frogs cannot simply pack up and move easily, especially when suitable habitat is scattered into small, isolated patches. A chorus in a healthy pond can seem to go on forever. However, those voices are now less common in many areas. The loss is not just depressing. Because frogs fill roles that other animals cannot, it alters ecosystems. Major declines have been caused by a deadly fungus, demonstrating how disease can change the natural world. There is a disease story in the frog world that moved like a shadow across continents. Frog skin is not optional, and it can be attacked by a fungal infection. They use it to balance salts and water, and part of how they exchange gases. When that system is disrupted, the body can fail in ways that look sudden from the outside. Even in seemingly intact habitats, populations rapidly declined in many locations. It was a stark lesson. Land protection is only one aspect of conservation. Invisible dangers that spread through trade, migration, and interspecies contact are another aspect of it. The fungus also showed how interconnected nature is. A single pathogen has the potential to spread, altering food webs and lowering regional biodiversity. When a frog vanishes, it can feel like one small animal lost. This disease revealed that millions of small losses can add up to a transformed world, fast. Some frogs survive fungus better due to helpful skin bacteria. On frog skin, there is a tiny community you cannot see, and it can change the fate of an animal. Some frogs carry beneficial bacteria that help defend against harmful microbes, including disease-causing fungi. These bacteria can compete with invaders, and in some cases, they can produce compounds that make it harder for the pathogen to take hold. This implies that the frog itself is not the only factor in survival. It may also rely on its microscopic skin-dwelling neighbors. Two frogs of the same species might face the same threat and have different outcomes, partly because their protective microbes differ. For scientists, this opened a hopeful direction. It becomes even more crucial to preserve the habitats that sustain the microbes if resilient populations are supported by healthy microbial communities. It also reframes what a frog is. A frog is not a single organism acting alone. It is a partnership, a living surface where biology and microbiology meet, and where survival can hinge on invisible allies. Road traffic can fragment frog habitats, blocking migrations to breeding ponds. Many frogs are faithful travelers. They may spend much of the year in one area, then move toward a breeding pond when conditions are right. The route can be short, yet it can cross roads that did not exist when the frog's instincts formed. A road can turn a simple journey into a gauntlet. Cars arrive fast, and frogs move slowly on dry pavement. Even when individuals survive, traffic can split populations into smaller groups that rarely mix, which reduces genetic diversity over time. The problem is not only the road surface, it is the fragmentation. A safe pond on one side may become unreachable from shelter on the other. In some regions, wildlife, tunnels, and seasonal road closures help, and the difference can be dramatic. When people guide frogs across during migration nights, it can look like a small act. In reality, it is protecting an ancient movement pattern that still drives frog life today. Night lighting can disrupt frog calling, changing who mates with whom. Frogs evolved their nighttime routines under darkness shaped by moon and stars. Artificial light can rewrite that environment. Bright streetlights near wetlands can make frogs more visible to predators, and that can reduce calling, because calling draws attention. Light can also interfere with timing. Some species are most active at certain light levels, and an illuminated shoreline can shift when they emerge, how long they call and where they choose to gather. When calling patterns change, mate choice can change too. A male that would have been heard in a dark corner might go silent under a lamp. Another may dominate simply because he calls from a shadowed spot. Over time, this can reshape breeding success in subtle ways, even when the water itself looks healthy. It is a reminder that habitat is not only plants and ponds, it is also the sky above them, and the rhythms of night that animals use as a signal to begin. Pesticides can affect tadpole growth. Even at surprisingly low doses, a tadpole's body is under construction, and construction is sensitive to what is in the water. In agricultural and suburban areas, pesticides can wash into ditches, ponds, and wetlands after rain. Even small concentrations can matter, because tadpoles live immersed in the water every day. These chemicals can alter growth rates, stress the immune system, or affect development in ways that make young less likely to survive to the next stage. The challenge is that the water may look clear and normal while the chemistry has changed. A healthy-looking pond can still carry an invisible burden. This is part of why frogs are often used in environmental mimicry. The effects can show up in the young first, and the consequences can echo through an entire breeding season. When fewer young reach adulthood, a chorus can fade in the years that follow. The story begins quietly, with a runoff event that seems small. The impact can become loud later, when the pond is missing voices. Wetland restoration often brings frogs back, sometimes within a single season. When a wetland is repaired, the response can feel like a return of music. If water is restored, native plants recover, and shallow edges form again. Frogs may arrive quickly, sometimes in the very first breeding season after restoration begins. They may come from nearby ditches, streams, and hidden pockets of habitat, drawn by moisture and suitable places to lay eggs. The first calls can be an emotional moment for people working on the land, because it is a sign that the system is becoming functional again. Frogs respond fast because they are tuned to water presence and shelter, and because their life cycles can take advantage of newly available pools. Restoration also helps more than frogs. Insects rebound, birds follow. The wetland becomes a living network again, not just a patch of soggy ground. This is one of the hopeful stories in conservation. Years may pass before damage occurs. However, recovery can start fast with the correct adjustments, and frogs are frequently among the first to report it. Captive breeding has saved some species, but reintroductions remain challenging. When wild populations collapse, conservationists sometimes turn to captive breeding as a lifeboat. Endangered frogs can be shielded from pollution, disease exposure, and habitat loss in controlled environments, allowing the species to endure. By using this strategy, extinctions have been avoided, and populations that may eventually reappear in the wild have been established. Yet returning is the hard part. In addition to needing adequate food, safe water, and a suitable habitat, a released frog must contend with the same threats that initially led to its decline. Reintroduction also requires careful planning, so the animals have the right genetic diversity and the right behaviors for survival. Some species depend on very specific breeding sites, and without those, release efforts can fail. Captive breeding is not a simple fix, it's a bridge. While people try to fix the world that a species needs, it can help it survive. The objective is always the same: a self-sustaining population that no longer needs a lifeboat. By recording frog calls, citizen scientists can map populations over time. You do not need a laboratory to help protect frogs. People can help by noting what they hear and when they hear it. As many species use calls to announce themselves, a short audio clip can become a data point that shows a species is present in a location, even if the animal stays hidden. Over seasons and years, these records can reveal shifts in range, changes in timing, and places where populations are growing or fading. This matters because professional surveys cannot be everywhere at once, especially in remote wetlands or small local ponds. Community recordings can fill the gaps, creating maps that are richer and more current. It also changes the relationship between people and nature. A listener starts to pick up on patterns, rhythms, and variations in voices, rather than just walking by a pond. The night starts to make sense. When a large number of people participate, the outcome is a sort of collaborative listening project that transforms disparate moments of focus into a more comprehensive image of frog life throughout an area. Aposematism is the use of warning colors by certain frogs to indicate danger. Bright skin can be more than beauty. In some frogs, bold colors act like a public sign that says, "Stay back." Predators learn fast because one bad experience can connect that color pattern with nausea, irritation, or a burning mouth. Over time, avoidance, rather than conversation, causes the message to spread throughout the local food web. Bad visibility can seem risky, yet it can reduce attacks overall, which makes survival easier than constant hiding. The colors can also work at close range when a curious animal is deciding whether to bite. These frogs move freely during the day in certain habitats because they use warning as a form of defense. The result is a strange kind of confidence in a small animal. Instead of bending in, it chooses to be seen, and it makes the world remember why that is a bad idea. Other frogs rely on camouflage patterns that break up their outline. Many frogs survive by becoming hard to notice, even when they are right in front of you. Their patterns have the ability to disperse light and shadow throughout the body, making it more difficult for predators to lock onto the outline. Some look like mottled bark. Others resemble pebbles, mud, or speckled leaf litter. This works best when the frog holds still, because movement gives the game away. Camouflage is not only color, it is posture and placement. A frog may press close to a branch, flatten against a rock, or angle its body to match nearby lines. In that moment, the frog becomes part of the background, and the predator's eyes slide past. This strategy is a quiet kind of power, because it lets a frog stay close to food and water without drawing attention. The most impressive camouflage often feels like a magic trick until you remember it is biology and patience working together. Certain frogs mimic dead leaves so closely they fool predators and people. Some frogs go so far as to disguise themselves in forests where the ground is covered in fallen leaves. Their bodies can be shaped and patterned to resemble a curled leaf, complete with uneven edges and vein-like lines. Because the brain anticipates seeing leaf shapes in real leaves, the effect is greatest when the frog remains motionless. A predator scanning for eyes and limbs may miss it entirely. Even people can walk past without noticing, until the frog suddenly moves and breaks the spell. There is more to this mimicry than just hiding. Additionally, since many hunters depend on sight during the day, it can aid the frog in sleeping. The disguise turns an exposed forest floor into a safe bedroom. It is a reminder that evolution can sculpt an animal to match a common object, and it can do it so well that your own eyes, which you trust, can be gently deceived. Eye spots on certain frogs can deter predators and divert bites. The predator often aims for the head, because one well-placed bite can end the chase. Some frogs use a deft illusion to counter that. When the frog feels threatened, it may exhibit eye spots on its sides or back, which can resemble big, staring eyes. An attacker may be startled for a brief moment by the abrupt appearance, and that moment may be sufficient to flee. Even when the predator commits, the full size can redirect the bite toward a less vital part of the body. Instead of striking the head, the predator may grab a flank, a leg, or a fold of skin. That still hurts, yet it can be survivable. This tactic turns appearance into a shield. It is not about being invisible. It is about being confusing at the worst possible moment. In the split second when life depends on reaction time, a painted illusion can change the outcome. A few frogs puff up to look larger, buying a moment to escape. When danger arrives, some frogs inflate their bodies like living balloons. Inhaling air causes the frog to swell, making it appear rounder and more difficult to manage. The goal is not to escape. It is not to fight. Becoming inconvenient is the aim. When a small meal suddenly appears too big too awkward, or too likely to become stuck, a predator that had intended to swallow it may change their mind. Additionally, because a swollen body slips away more readily, inflation may make the frog more difficult to hold. In some cases, the posture changes too. To look even larger, the frog raises itself, stiffens, and angles its body. It is a bluff, yet it is a useful one, because hesitation is time. Time flies by. Time is a dive. Time is a chance to reach cover. This tactic demonstrates how buying seconds, rather than winning a fight, can be the goal of defense. Some frogs secrete sticky mucus that makes them hard to grab. The skin of a frog is capable of producing more than just moisture. In some species, the secretion becomes thick and sticky, turning the body into something that feels like it belongs to the swamp itself. For a predator, that stickiness can gum up a mouth or glue fingers, which makes holding on difficult and unpleasant. While the attacker is distracted by the sensation, the frog might escape. The mucus can also reduce friction against surfaces, which helps the frog slide into crevices or under vegetation. This defense is especially effective because it changes the rules of contact. A predator expects skin and muscle. It gets a sticky mess that complicates the grip and slows the chase. For humans who handle frogs for research, this can be memorable because the residue can cling and stretch like soft glue. It is an on-demand chemical escape tool that makes a close encounter into a problem the predator did not anticipate. Certain frogs have bony skull spines that can help in defense. Not all frog defenses are soft. In some species, the skull can include ridges or spines that make the head tougher and more dangerous to bite. In areas where it anticipated a smooth meal, a clamping predator may encounter hard bone. This can discourage repeat attacks, and it can increase the chance of being dropped. The skull shape can also help the frog wedge itself into narrow shelters. A hard, angular head can brace against rock or wood, making it harder for something to pull the frog out. That is a different kind of defense, one based on structure rather than chemistry. It alludes to a life lived in close quarters, where a powerful head serves as both a tool and a shield. These frogs remind us that amphibians are not always delicate. In the most crucial area, directly behind the eyes, where a single bite could otherwise be lethal, some people wear armor. A few species play dead, becoming still when handled. Sometimes the best move is to do nothing. A few frogs respond to threat by going limp and motionless, as if life has already left the body. A sudden stillness can disrupt the pattern of movement that predators frequently use to confirm prey. An attacker may loosen its grip, lose interest, or shift attention to something that looks more alive. This strategy can also reduce injury during handling, because struggling can trigger harder bites and more shaking. Playing dead is risky, because it depends on a predator choosing to release. However, it can be surprisingly effective in certain situations. Once the pressure eases, the frog can spring back into action and vanish into cover. The contrast is part of the trick. One moment, it is a lifeless object. The next, it is gone. It is a reminder that in nature, escape is not always about speed. Convincing an adversary that the pursuit is already over is sometimes the goal. Certain frogs can jump into the water and disappear with hardly a splash. A frog at the water's edge often has one plan ready, and it is fast. When danger appears, it can launch into the water with a clean arc, then disappear before the surface settles. Since sound and ripples can direct a predator, it is important that many frogs enter at an angle that minimizes noise and spray. The frog can press against mud, tuck into weeds, or remain motionless next to sticks and stones that disrupt its shape once it is submerged. The water becomes a second landscape, full of hiding places that are invisible from above. The leap is only one part of the escape. It is the disappearance. A predator may reach the bank a heartbeat later and find nothing but calm water and a few drifting rings. That vanishing act is one reason frogs thrive at edges. The boundary between land and water is dangerous, yet it offers a trapdoor. The pond is more than just home for a frog with good timing. it is refuge. The soundscape and identity of Puerto Rico were shaped in part by the coqui frog. On warm evenings in Puerto Rico, a small frog can become part of the island's heartbeat. After sunset, the distinct and unmistakable call of the coqui reverberates through gardens, hillsides, and neighborhoods. People grow up with that sound, so it becomes tied to memory, place, and home in a way that is hard to explain until you have heard it night after night. The call also marks territory and attracts mates, so the sound is doing real biological work while it shapes human culture. When coquis are absent, the night can feel strangely empty, as if a familiar instrument has dropped out of the song. When they are present, they turn ordinary darkness into a living chorus. It serves as a reminder that wildlife can become a part of one's identity and is not just something that can be seen. Ancient cultures linked frogs with rain and fertility across many continents. People saw patterns that were impossible to ignore long before modern biology. When it rains, frogs frequently show up, and during wet seasons, their calls can become more frequent. That timing made them natural symbols for water, renewal, and the return of life to dry ground. In many cultures, frogs show up in stories, art, and ritual objects because they seem to announce the moment when fields would green again and rivers would rise. Practically speaking, the connection also makes sense. Where there is water, there are frogs. Wetlands and ponds are typically bustling and productive places for frogs to live. That connection between frogs and abundance became part of how people explained the world and how they hoped to influence it. The frequency with which the same concept emerges in far-off locations without communication is startling. Different languages, different landscapes, and the same observation. When rain returns, frogs return. A symbol was born from a shared experience of seasons. In order to study gravity and balance, frogs have flown in space. Because a frog's body is designed for movement, it can show how gravity changes. In space, researchers have used frogs to study balance. When up and down lose their typical meaning, the nervous system reacts, and orientation changes. Frogs have inner ear structures that help detect motion and position, and those signals guide swimming, jumping, and writing reflexes. In microgravity, familiar cues vanish, and the brain must interpret a new sensory world. Observing how frogs adjust can help scientists understand basic vertebrate physiology, and it can also inform how humans adapt during long missions. There is something poetic about it. An animal shaped by ponds and forest edges has helped explore the emptiness above Earth. It is a reminder that space research is not only about rockets and machines, it is also about living bodies and how they stay coordinated when a fundamental force is changed. Frog embryos help scientists understand how vertebrate bodies form in early development. Because changes occur swiftly and visibly, a frog embryo is similar to a living diagram. For decades, scientists have studied frog development to learn how a single fertilized cell becomes a body with a spine, organs, and a patterned layout. Early stages reveal how cells divide, move, and take on different roles, and those patterns can be observed without the complexity that comes with larger animals. This work has helped researchers understand concepts like body axes, tissue layers, and how signals guide cells toward becoming muscle, nerve, or skin. It has also helped researchers uncover how early errors can result in significant changes down the road. What makes this powerful is that frogs are vertebrates, which means many of the same basic developmental rules apply across a wide range of animals, including humans. Studying an embryo the size of a small bead has helped reveal the hidden choreography that builds a backbone and a beating heart. Medical research on heart function and pain management was influenced by certain toxins found in frogs. In the natural world, a chemical that protects a frog can also become a clue for medicine. Because they interact with muscles, nerves, or signaling pathways in ways that may influence drug design, certain compounds found in frog skin have drawn attention from researchers. Scientists do not take a toxin and turn it into a pill overnight. They study how it works, what it targets, and what parts of the molecule might be useful when modified and carefully dosed. This process has helped explore new ideas in pain control and in how hearts regulate rhythm and strength. The bigger story is that evolution has been running chemistry experiments for millions of years. A frog that survives predators by producing a powerful compound is also revealing a biological mechanism that humans may not have discovered otherwise. It is a reminder that biodiversity is not only beautiful, it is informative. A small amphibian can carry a chemical lesson that reaches into laboratories and hospitals. The African clawed frog aided early pregnancy testing, shaping medical history. Before modern rapid tests, pregnancy detection was slower and less reliable. In the mid-20th century, the African clawed frog became part of an unusual medical method. When certain hormones are present, these frogs can respond in ways that helped indicate pregnancy, and the results could arrive faster than many other options of the time. The practice spread widely in some regions, and it shaped how clinics approached early confirmation for years. This history also reveals how science and society intertwine. An amphibian from southern Africa became linked to human healthcare across oceans, and that link changed demand, transport, and research focus. It is a surprising chapter where biology, medicine, and global movement meet. It also reminds us that scientific tools evolve. What once required living animals can now be done with small chemical strips. Yet the frog's role remains a vivid example of how humans have relied on other species to answer intimate questions about our own bodies. Some frogs can live surprisingly long, especially in cool, stable habitats. A frog can seem delicate, yet some species can persist for many years when conditions are steady. Cooler climates and stable environments can slow metabolism and reduce stress, which can support longer lifespans. In the wild, harsh seasons, disease, and predators all influence survival. Therefore, living a long life is a feat attained by making numerous narrow escapes. Some frogs have been known to live for decades in captivity, where food and safety are guaranteed. Longevity changes how you think about a frog's life story. It is not always a brief summer creature. A long-lived frog can witness repeated seasons of drought and flood, and it can return to breed many times across its life. That matters for populations, because older adults can stabilize numbers when a few breeding seasons go badly. When you hear frogs calling, you may be listening to individuals with years of history behind them, not just a single season of life. Many frogs return to their birth ponds, guided by smell and memory. A breeding pond is not always chosen at random. Many frogs return to the same general area where they were born, exhibiting a sort of hometown loyalty. The journey can cross forest floor, fields, and rocky edges, and it may happen under cover of night or after rain. Smell plays an important role, because water and soil carry chemical signatures that can act like landmarks. The landscape becomes a map made of scents, moisture, gradients, and familiar pathways. Because the frog is returning to a location that has previously worked, success can be increased by returning to a known site. However, it also makes people vulnerable. Frogs may follow their natural tendency to return to an area that no longer supports them if the pond is contaminated or drained. This is why it's so important to preserve breeding wetlands. These puddles are not interchangeable. For many frogs, they are destinations, remembered and sought out across seasons, like a promise kept. The skin of a frog has the ability to taste, identifying chemicals in water and on prey. A frog's skin aids in reading the chemical information that surrounds it. Many frogs have sensory cells in the skin that can detect dissolved substances, which makes sense for an animal that lives in constant contact with moisture. This ability can help a frog assess water quality, locate suitable habitat, and respond to the presence of other animals nearby. Because chemicals on prey or in the water can indicate what is edible, what is dangerous, and what is worthwhile pursuing, it can also affect feeding. The result is a kind of distributed sensing. Instead of relying only on eyes and ears, The frog can gather information through its surface, almost like the environment is touching back. This makes frogs especially sensitive to changes in water chemistry, and it also makes their behavior more understandable. A frog may avoid a pool that looks perfect to us, because the skin is detecting something we cannot. Our senses don't fully capture the richness of its world. Some frogs hibernate underwater by absorbing oxygen directly through their skin. Certain frogs spend months at the bottom of ponds or slow streams during the winter. And unlike mammals, they do not have to come up for air. Cold water holds more dissolved oxygen than warm water, and a frog's slow winter metabolism needs less fuel. The frog can stay mostly motionless while absorbing enough oxygen from the surrounding water thanks to its gas-exchanging skin. It must choose the right place. The bottom cannot be totally stagnant, and the water requires oxygen. The frog also needs to avoid freezing solid in the wrong conditions, so depth and flow matter. This survival method turns a pond into a winter shelter, not just a summer home. When spring arrives, the frog rises back into the active world, and the same body that endured underwater stillness can soon be calling again at the surface. It is a seasonal magic trick powered by physiology and cold water chemistry. The Suriname toad carries eggs in skin pockets until tiny toads emerge. This is one of the strangest forms of parenting in the animal world. After mating, the eggs are pressed onto the mother's back, and her skin swells around them. Each egg ends up in its own small pocket, like a living nursery stitched into the body. The young grow safely inside those pockets, shielded from shifting water levels, drying air, and hungry fish. Weeks pass, and the back looks patterned, almost like a honeycomb of small chambers. Then the time comes. Fully formed young toads emerge from the pockets, ready to face the world without a free-swimming tadpole stage. It seems unthinkable until you see it explained, at which point it becomes unforgettable. This isn't a pond-built nest. It is a nest that is carried everywhere, transforming one parent into a delivery system and a shelter. Darwin's frog fathers can raise young inside a vocal sac. In this species, fatherhood becomes a form of careful carrying. When the eggs hatch, the male collects the small offspring and leads them into an area that is associated with his voice. The same area used for calling can become a safe chamber, where the developing offspring stay moist and protected. While they grow, the father must balance survival with caregiving, and he cannot treat the days the way a carefree frog might. There are still predators. There is still hunger. Yet the young remain tucked away, sheltered from dangers that would pick them off in open water. When development reaches the right point, the father releases them into the outside world. The image is striking. A voice becomes a cradle. A call turns into a doorway. It is a reminder that frog reproduction is not only about laying eggs and leaving. In some lineages, it is about carrying the next generation in the most surprising place. The Goliath frog can build stone nests, moving rocks with its body. A large frog may perform an activity along some forest rivers that resembles construction work. A Goliath frog can shift stones with its body and legs, clearing and arranging a space that helps create a safer place for eggs and young. Beauty in architecture is not the aim. It is a useful nursery, frequently in shallow water, where the placement of rocks can regulate depth and flow. Moving stones is demanding for any animal, and it reveals just how powerful these frogs can be. It also shows planning. The frog is not only reacting, it is shaping the environment, so the next stage of life has better odds. In a river that changes with rain, a stable pocket can matter. When you imagine a frog as a builder, you start seeing amphibians differently. Some do more than survive a habitat. They alter it. The purple frog has a narrow snout for termites and lives underground. This frog appears to be from a different era. It spends most of its life underground, hidden in soil, where humidity is steadier and temperatures swing less. Its body is built for that darkness. The narrow snout on the head helps it dig through the ground and consume termites, which are common underground. It can appear clumsy and slow from above. Below ground, it is in its element. It may surface only briefly during heavy seasonal rains to breed, then disappear again into the hidden world of tomals and roots. This lifestyle means many people could live near one and never know it exists. When it does appear, it is a reminder that biodiversity is not always loud or visible. Some of the most peculiar frogs don't sit on leaves. They are buried beneath them, living a secret life in the soil. The tomato frog can ooze sticky secretions that irritate a predator's mouth until the first bite teaches a lesson. A bright red frog may appear to be an easy target. The tomato frog can release a thick secretion when threatened, and the effect is more than slipperiness. A predator may recoil, spit, or wipe its face in discomfort if the material irritates its mouth and eyes. That reaction creates the opening the frog needs. In a moment of confusion, the frog can scramble into cover or simply be dropped and left alone. The defense is also memorable, which helps the frog in the long run. Predators that learn once may avoid that shape and color again. It is a chemical boundary delivered instantly through skin. The frog doesn't require quick claws or sharp teeth. It needs a strong message and a way to make the message unpleasant to ignore. In the forest, that kind of deterrent can be worth more than speed. To prevent water loss, the waxy monkey tree frog spreads its skin oils. Some tree frogs live in places where dry air can arrive quickly, even when the landscape is green. For that issue, the waxy monkey tree frog has an ingenious solution. It has the ability to secrete lipids from its skin and use its limbs to disperse them throughout its body, much like a protective layer. That oily layer helps slow water loss, which can allow the frog to rest through drier periods without dehydrating as fast. The behavior looks deliberate, like grooming, and it turns the frog's own chemistry into a survival tool. This matters because tree life exposes animals to wind and sun, and moisture can evaporate quickly high above the ground. The frog purchases stability and time by controlling the surface of its skin. It can choose when to move and when to stay still, rather than being forced into constant search for dampness. It is a silent illustration of how amphibians can use straightforward, consistent behavior to solve a challenging problem. The hairy frog can break toe bones to form temporary claws. This defense sounds like a myth, yet it is rooted in anatomy. In the hairy frog, certain toe bones can be pushed through the skin to create sharp points that function like claws. The frog does not grow true claws like a cat. It creates a temporary weapon by using its own skeletal structure in an extreme way. The idea is grim and impressive. When threatened, the frog can turn its feet into something that can scratch and deter an attacker, especially in close quarters. Later, the body can heal and the bones return to their usual position. This is not a strategy for everyday life. It's a last option. That makes it even more startling because it shows what some animals are willing to do when escape is not possible. When the circumstances call for it, a soft amphibian can suddenly turn dangerous by using its bone as a tool. Some frogs glide between trees using webbed feet and stretched skin. Some frogs have developed a method of moving through the air with greater control because falling under thick forest canopies can be lethal. Gliding frogs can launch from a branch and spread wide webbed feet, sometimes with extra skin along limbs, creating a broader surface that catches air. They do not flap like birds. In order to transform a drop into a controlled glide that can transport them to another trunk or leaf cluster, they steer and slow. This ability can help them escape predators, reach food, and move without climbing down into the dangerous world below. It also changes how the forest is used. The canopy becomes a connected map of routes, not isolated perches. For humans, the sight can be astonishing. A frog does not just fall, it takes to the air. It sails. The skill is a reminder that flight is not only wings and feathers. Sometimes it is webbing, posture, and a body plan that makes the most of the air between trees. A few frogs can survive in brackish water near coastal mangroves. Most frogs are closely tied to fresh water because salt can disrupt water balance in the body. Yet a few species manage life where rivers meet the sea. in habitats like mangroves and coastal marsh edges, where the water can be brackish. Surviving there requires careful control of salts and hydration, and it requires behavior that avoids the harshest conditions. These frogs may choose microhabitats where rainwater dilutes salt, or they may time activity around tides and freshwater pulses. Living in brackish zones can offer advantages because some predators and competitors are less common there, and the habitat can be rich with insects. It also places frogs in one of the most dynamic environments on Earth, where salinity, temperature, and water level shift constantly. When you think of a frog, you may picture a woodland pond. These coastal survivors remind you that amphibian life can push into salty borderlands, finding narrow pathways where physiology and habitat line up. Frogs evolved many times into similar shapes, showing nature repeats winning designs. Frogs that are not closely related can end up looking remarkably similar all over the world. A stream specialist in one region may resemble a stream specialist far away, because fast water rewards similar solutions. A burrower may resemble another burrower on a different continent because digging favors certain shapes and strong limbs. This is convergent evolution, and it is one of the most fascinating patterns in biology. When the same challenges appear again and again, evolution often returns to similar answers, as if nature is testing designs and keeping what works. Because they have so many different lifestyles, frogs make this easy to see. Tree climbers, ground hiders, water racers, and desert waders all exist within the group, and similar roles can produce similar bodies. It's a humble lesson. Evolution is both practical and creative. When a design solves a problem well, it can appear more than once, independently, like a melody discovered by different musicians. Several frogs can climb smooth surfaces using toe pad adhesion and posture. It can be like watching gravity lose a battle when you watch a climbing frog. It can scale a slick leaf, creep along a vertical trunk, and sometimes cling to glass after rain. The secret is not strength alone. The toe pads make close contact with the surface, and a thin layer of moisture helps create strong grip through friction and adhesion. The frog then uses posture like a careful rock climber. It spreads limbs to share load, maintains a close center of mass, and positions each foot at specific angles to maximize contact. On rough bark, it can use texture. On smooth surfaces, it relies on precision. This ability opens up a three-dimensional world where food and safety can be higher than most predators can reach. It also turns ordinary surfaces into roads. A wall is not a barrier. It is a path, climbed one quiet step at a time. As we come to the end of our journey, it helps to notice just how much ground we've covered together. We moved from quiet ponds to rushing streams, from forest floors to treetops, and even into places hidden underground. We followed lives that begin as drifting eggs, transform into swimmers, and later step onto land with lungs, legs, and voices. We listened to calls that fill warm nights, watched bodies adapt to cold, drought, height, and darkness, and glooped the many ways frogs solve the simple challenge of staying alive. Along the way, these small animals revealed big ideas. They showed how water and land stay connected, how balance can be delicate, and how survival often depends on timing, patience, and flexibility. Some stories were loud and dramatic, others were quiet, unfolding slowly beneath leaves, skin, or still water. Together, they form a world that is ancient, resilient, and endlessly inventive. Now, there is nothing more you need to hold on to. Let the images soften. Let the sounds fade into something distant and steady, like a pond settling after a ripple. Allow your breathing to slow, your shoulders to soften, and your thoughts to drift without needing direction. Everything you've heard can rest where it is. If this journey settled your thoughts, there are other, quiet places waiting nearby. Through the world of frogs, you can always check out another video that might be waiting for you if you haven't fallen asleep yet. Additionally, if these nighttime adventures make you feel better, A simple comment, like, or subscription can help others find their way here as well. For now, however, the day can let you go. The night can take over. Sleep well, and good night.